Good day, class. This is a review pre-quiz review clip on adding vectors using the parallelogram rule. So let's write down the title for this lesson. So entitle this pre-quiz review on vectors. All right. So let's write down the learning objective. The learning objective for this part of the lesson, learning objective, is as follows. By scoring 75% or higher on the quiz, you you will apply the parallelogram rule in adding and subtracting vectors. In adding and subtracting vectors. Okay? So if you can score 75% or higher on the quiz, then you've met the objective of this lesson. Okay? So now you can bring out the worksheet on vectors, and we're going to try out some examples that will look like what you will see on the test. Okay? So let's take a look at this. Let's do P plus Q first. Okay? Example 1, P plus Q. So vector P, if we look at this, vector P is basically 1, 2, 3, 1, 2, 3, 4, 5, 6, 3, 6, right? Because this right here is the origin or the tail of the vector. So 3 in the x direction to the right and 6 units up. Since we're adding it to Q, let's figure out what vector Q is. This is the tail of Q right here. Put your coordinate system 0. So starting from there, you're going to go 1, 2, 3, 3 to the right, and 1 unit up. Alright? So we're going to use the parallelogram rule to figure out what P plus Q is. Since both of them are in the first quadrant, we're going to make our first quadrant pretty big so it can fit in there, right? So put our y-axis to the left and bring our x-axis really low so that it fits, okay? All right, let's draw vector P. Vector P is 3 to the right, 1, 2, 3, and 6 units up. 1, 2, 3, 4, 5, 6. Boom. Please, please, please do not draw line segments. You have to use a directed line segments. Or make sure you have an arrow, okay? Arrows are critical here. Okay, to indicate the direction. Now let's look for vector Q. Vector Q, you start from 0. You go 1, 2, 3, and up 1. Okay, that goes back to Q. We just drew the two vectors. Now how do we add them? Using the parallelogram rule, it requires us moving one vector to the tip of the other one, and then we're going to create the parallelogram. So then how about we label them first and then determine which we want to move. So this is P, and then this one right here is Q. So let's move Q to the tip of Q. How do we do that? Just simply use these numbers, right, for your direction. So we're going to go 1, 2, 3, and up 1. Please use a dotted line for this P right here, for this Q right here. And then P, use a dotted line also to complete your parallelogram. Am I done? No. The answer is the diagonal starting from the two tails. Okay, if I start from the two tails where they both meet right here and I draw this diagonal, down. There goes your answer. Okay, and do indicate it. That is P plus Q. Now, using the coordinate system, what are the coordinates of P plus Q? It's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6, comma, 1, 2, 3, 4, 5, 6, 7. 7. So is our answer correct? I don't know. We can determine it by computing P plus Q, right? By adding these 2 to verify if our answer is correct. So we can just simply plus them, P plus Q, by adding the coordinates, and that's going to give us 6, comma 7. Perfect. Our answer checks out correctly. Okay. All right. How about P minus Q? Let's do the second part for this number 2. How do we do this one? Vector P stays the same. Vector P is 36, but we're doing negative Q this time. So negative Q is going to be what you get when you distribute minus to these two. So it's going to be negative 3, negative 1. That's what negative Q is going to be. All right. This is in quadrant 1. This is in quadrant 2. I'm sorry, quadrant 3. So we need to put our y-axis right in the center. Not the y-axis, I meant to say. The coordinate system can go in the center. And then we know vector P is longer to the top, so we can put the x-axis a little bit lower. So we'll put it somewhere here. Okay? Now let's draw the vectors and add them using the parallelogram rule. So we're going to go 1, 2, 3, and go up 1, 2, 3, 4, 5, 6. Okay? So that will be vector P. From here all the way to there is vector P. And then negative Q, you go down 1 and over 1, 2, 3. Right there, that will give us vector negative Q. Okay? So this is P, and this is negative Q. Now to add them, we need to copy this vector to the tip of the other one. So if I copy negative Q up here, I need to go down 1 and over 1, 2, 3. And then I'll draw my my vector using a dotted line. Okay, so same direction going down. Now we can complete our parallelogram by following the direction of P, which is upwards, and starting from the tip of Q, like that. Okay. So what is our answer going to be? Well, our answer is going to be right on top of here. This is where our answer would be. Okay, there goes our answer. It's right on the y-axis, which is kind of interesting. So this is our answer right here. This portion, I don't know if you can see it. So that is vector P minus Q. So what are the coordinates of going from here and ending right there? What are the coordinates going to be? It's a movement only along the y-axis. X stays at 0, so that our answer is going to be 0, comma, 1, 2, 3, 4, 5, 0, 5. Okay. Is our answer correct? Well, I have no clue. Let's verify by combining these two. By combining these two, we'll have we will have vector P minus Q. Okay. So P minus Q is going to be, cancel that, 0. 6 minus 1 is 5. Oh, that's good. Our answer is correct. All right. Now, there are 2 other questions that are going to be seen on the quiz that involves components and direction. Okay? So, pay real close attention to this. Number 3. Number 3 is find the horizontal and vertical components. Of vector S. Okay, I have some random vector s pointing in that direction, and the components, this is the x component, and this is the y component. Alright, so vector s has a direction or angular direction of 20 degrees, and it's 33 newtons strong. Okay, so this right here is vector s. Vector s. Let me put it on the side. So this is vector s. Okay? Alright, so what are the horizontal and vertical components of vector s? If we use SOHCAHTOA, we know that this side, this is the angle, so this is opposite, right? O. And this is the adjacent A. So, to find a component, this is the vertical component, and this is the horizontal component, okay? So which one has, in SOHCAHTOA, which one has O? Which one has O in SOHCAHTOA? Let me write it down on the side. SOHCAHTOA. So tan doesn't really count here. I need you to sine or cosine. Remember, this is the y. This is the y part. Is y sine or cosine? Remember, y is always sine, right? So guess what the horizontal component is? Very easy. Watch this. So the horizontal component is y. So it's simply going to be 33 sine 20. Okay? Because this is the y component, and y is sine. So you just simply go, the vector sine of the angle will give you this component right here. Okay, remember always from SOHCAHTOA, so this is how that works. To find the, oh, I got it confused. This is the vertical component. Vertical component. For the horizontal component, horizontal, is this one, right? This is A from A, so ka, A, and this is H. So what is this going to be? Sine or cosine? Obviously, the x-axis, and if you look at your formula sheet, you remember that the x-axis is always cosine. So it's going to be exactly the same as the top. The only difference is that you're going to have cosine instead of sine. So the horizontal component is simply 33 cosine 20 degrees. Simple and short. That's how it works. Okay? So this is example 3. Now, let's try another example. Let's do 3b. What if we had something like this? What if we had a vector like this, and you are asked to find a horizontal and vertical component? So this is, oops, not parallel. This is the vertical component, and this is the horizontal vertical component. If this were 15 newtons, and this were um, 10 degrees, let's call this vector t. Vector t. All right, what would the vertical and horizontal components be? We simply know that this is the opposite, which is the y part, and this is the adjacent, which is the x part, right? Remember, opposite or y part is always from so, which is sine, and this is cosine, right? So your vertical component is going to be what? What is your vertical component going to be? Vertical component is simply the y component of this vector, which is the sine, so simply 15 sine 10 degrees. And the horizontal component, same thing, only thing you change is the function, which is cosine, so it's going to be 15 cosine 10 degrees. And that's how you find the components, all right? Okay, now let's take a look at one last example, and that'll be that. This has to do with direction. So in this one, you need to find the magnitude the magnitude and direction. And direction. All right, so for this one, let's say we have a vector like this, vector P, and they already gave us the components. Components are, this is the x component right here, and there goes the y component right there. Let's say the x component is 3, and the y component is 5, and your angle is alpha. So it's asking you for what is the value of alpha, that's the direction, and then how long is this. So to get the direction, all you simply do is you have, this is your opposite, and this is your adjacent. What trig function has opposite and adjacent in SOHCAHTOA? SOHCAHTOA, opposite and adjacent is tan, right? So you're gonna go tan alpha equals opposite over adjacent. So how do you get alpha by itself? You do the inverse tan of both sides. So inverse tan of tan alpha, inverse tan of tan alpha equals the inverse tan of 5 over 3. Alright, so direction is always inverse tan. So your answer is going to be, alpha is simply going to be the inverse tan of 5 over 3. Alright, so that's basically what your direction is going to be. And then you can plug that into the calculator to get the approximate result. Okay? Let me see if my calculator here can do it. So alpha is going to be approximately, let's see, 5 over 3, 5 divided by 3, and then if I take the inverse tan, 59.04. Let's speed it up, 59.04. Okay, so that's the magnitude, that's the direction of this angle right here, direction. Now how do you find the magnitude? Magnitude is easy. That one is just simply a squared plus b squared equals c squared, okay? So c is a magnitude, so for magnitude, you just simply use Pythagorean theorem, which is c squared equals a squared plus b squared. Okay, what's a, what's b? This can be a, and this can be b, right? So if I get c, that's my magnitude. So c squared equals 3 squared plus 5 squared. So c squared equals 9 plus 25. C squared equals 34. Hence, c equals the square root of 34. So your magnitude is 34. Alright? So that's basically that. Okay. So thanks for watching this clip. Hopefully you do well on this quiz.